today I will talk about permafrost temperature mostly, but because there is no Misha and no Yuri, I may say something about ice content as well. But well, probably some of you know better than me the ice content here, and I will talk not about through the bay only. I will talk about whole road in front of us for the next 2 or 3 days. But you will see some slides which are showed already, but I will show them for a little bit different reason here and talk a little bit different things. So most of you actually saw the slides, some of them you not, but maybe you saw it somewhere else.
Yeah. I know, just trying to find the mouse.
Okay. I'll stop working. No, this thing works. It's probably relates to. It relates to the.
You want me to stop sharing?
Zoom, yeah.
Stop
If you
sharing.
stop sharing and then share first, and then open it.
That's what I did before. So.
And it worked.
Yeah.
We get a really good view of your thinking face.
I'm glad I'm not full
Yeah, they
screen.
shared this one. Yeah.
This is exactly what we did before. Just saying.
Works.
Okay.
So what I will be talking today is this concept, what was established by Professor Tom Osterkamp and added after him. And we continue to record data. So this red squares is our sites we may not visit, but see it from a little bit of a distance. There are a couple of them near to the road. And I will show the picture, one of them. The green one is USGS, deep boreholes. So all these squares are deep boreholes, deep like 50 meters and deeper. Some of the USGS boreholes actually much deeper, up to like 600, 800 meters. So that material from this data collected for the last almost 40 years, more or less continuously, that I will be presenting. And so there's somebody we can recognize here. And this picture didn't change at all. So that was about what, 18 years ago or something like that. Yeah. And running actually. So this picture. So each side is has deep borehole, and some of the boreholes have sensors in it already, or most of them actually I measure manually. And also we have some air temperature, snow depth, and temperature in shallow 1 meter depth every say 10 centimeters snow, surface temperature and ice content in I'm sorry, unfrozen water content in the upper in the Arctic layer. So that's the sites which doesn't have this kind of set. So whereas just borehole and I measure it manually once a year. So as a result of these measurements, we have these temperature profiles. It's just example of one of them for borehole, depth course borehole. So this is the depth. This is the temperature. Depth starts at 20 meters. It means there's no seasonal variations involved here. It's and each line is it's about 2 years in between, and that's what record. This one is a little bit older, so we have already 2023 line here. And what it shows is in the beginning of our measurements in the early 80s, it was a little bit of moving temperature back and forth a little bit. See, there was even a little bit of cooling in the late 80s. But after late, it's always going up and up and up, getting warmer and warmer and warmer. And last 5 years, it's also warmer. So last 3 years, it will be a little bit of cooling on the top, which you can see from this graph. Well, I showed later. Next one after this. But looking at the whole, it's going to take some time to change, but okay, I will not go back. So what I will talk today is not just about the cold sites, which I was talking in Barrow, but all the transect. And this is representation of all transect in a little bit different way. So it's a 20-meter depth and 50-meter depth temperatures in time. We see two things here: increasing temperature, which I talked already about it, but also this increase in temperature is a little bit different. And for the northern sites, it's very kind of understandable, very straightforward. So the most northern sites increase colder first of all, and increase in temperature is larger. When we go from West Dock, which we may visit today, that course we will probably visit or see it on the road tomorrow. Franklin Bluffs about 40 miles south from airport, and then Valparaiso Lake and Happy Valley. So the temperature is normally kind of increasing with going south, which is perfectly understandable because air temperature increasing going south, and also increase in snow depth as well going south. So just a little bit about permafrost here. I maybe mentioned, maybe not. It's the deepest permafrost measured in Alaska is around Prudhoe Bay. It's about 650 meters. So that's the deepest measured permafrost in Alaska. And not the coldest one. The coldest still in Barrow area and that area there. So going south, the picture is much more complex, really. If you look like there is climatic gradient also exists, but the permafrost temperatures are a little bit more kind of not following this climatic gradient. And that probably explanation for that is that for the northern part, the permafrost is mostly driven by climate because not of much of the vegetation. So when you go in the southern portion, actually starting from Chandler Shelf, which is in a Brooks Range, that's already much more impact start to play vegetation type, surface conditions, and snow accumulation. So that's why we can see in the southern part, we can see, the coldest actually right now, the coldest temperature is at College Peak, which is in Fairbanks. So that's the coldest temperature. And it doesn't mean that temperature in Fairbanks is colder than anywhere else. It just means that for this particular site, because of accumulation of peat and some specific vegetation, permafrost temperature is colder than anywhere in our sites starting from Chandler Shelf. So that's a good example how natural other components of the natural environment impact permafrost temperature. So that's a good example. In general, in the southern part, when we started, temperatures were colder. Now it's warmer, and it's interesting again that the coldest side temperature increase, much faster. In warmer sites, there is some of the sites like Livengood. There is no changes, almost measurable changes at 15-meter depth for the whole period of measurements. Though we know that climate is warming.
So at the tunnel, it's been minus 0.8 for decades. So
Was that
at the tunnel, it's been minus 0.8. Just at a like 15-foot depth. forever.
Yeah.
Yeah, I mean, it hasn't changed.
Yeah, minus 0.8, minus 0.6.
Yeah.
That's what we see like Lemonwood. It's a minus point, 68 or something like this. And it was like this for a long period of time. We can talk about it. It's understandable. And paper was published on about this whole paper.
Is that latent heat versus
It's
sensible
latent heat effect, yeah.
Okay.
And for those who are interested, we can talk separately, or I can, if I don't have time, I can, during the driving bus, I can give you this idea about what's going on. We know what's going on and why it's happening. Everything is good. So climate is warming and permafrost is changing, but sometimes temperature is not good indicator of changes in permafrost. In this case, the liquid water content is much more clear parameter to look at when you want to see the impact of climate warming. All right, so that's kind of general view on the whole concept. Now about ice content a little bit. Again, probably not the best person to talk about it. So in the Prudhoe area, there's, you can see already, so the ice wedges are still there. And they're pretty big. However, there is a gravel layer below the fine grain, like silt material, not too far down. So it's shallower here than in Barrow area. So gravel is typically somewhere between 1.5 meters and maybe 4 or 5 meters in the area. So it means that this ice wedge is penetrating in that gravel, but most of the ice really concentrated in the shallower, closer to the surface depth than compared to the Prudhoe area. However, when we will be leaving toward, going down south, there is a belt of this very ice-rich permafrost which hit the Point Lake. So it's pretty much the same belt of Romanovsky. So there will be the same situation which was in Point Lake. So deep, syngenetic, big ice wedges there. Then when we go into Brooks Range, of course, ice content is very different in places depending on amount of or burden, how much of the weathering and fracturing in bedrock is. So ice content is very, very variable. Then we will go on the south side of it, and here will be also some areas, including Fairbanks, where we again will go into Yaduma, this very, very big ice wedges. And for those of you who will go to the tunnel, or who already was in the tunnel, not that tunnel in Barrow, but Permafrost tunnel in around Fairbanks Fox, Permafrost tunnel, you will see these ice wedges from inside much better than you saw it in Barrow. So we went again into the very icy permafrost when we will go down to the interior. So that's very, very general about what you should expect. And of course, because of changes in ice content and form of the ice wedges, the result of degradation of ice wedges will be also a little different. So here, typically, you will see the same high centered polygons of you. So in Barrow, in the farther south, I'll show a few pictures. There could be a little bit more dramatic, actually, situation with degrading permafrost. All right. Let's start working. Oh, it's,
No,
maybe I should stay in. Oh, you
Yeah,
did.
I just-
Okay, I will just. All right, you saw it already. Let's go. Yeah, I don't have to say anything more than I said already. So that's our projection. So just coming back to this, the layer of protective layer above the ice wedges. So I just want to make a short point that when this is the active layer depth, and this is for death course. So see, lately we had the active layer somewhere about 72, 73 centimeters. And of course, some of ice wedges were melting on top. But then last 3 years, the active layer depth drops to somewhere like 65 centimeters. So immediately you will create this. Oh, okay. This protective layer, but it's just temporary. All right. Let's go further. So this we can skip actually cold part. Yeah, you know already. Yeah, we talked about that. So this is just to remind you, because I will talk about the potential freezing and thawing in the Fairbanks area. So again, in the cold permafrost like here, the potential freezing is between 1.5 to 2 meters in natural conditions with snow, and potential thaw is less than 50 centimeters. Okay, we can go further, further. Now, even further. Yeah, I already talked about it. Okay, so now just a little bit of what's going on around Fairbanks. In this example where I was kind of trying to scare people for North Slope, like in 60s, 2060s and 70s, you will feel like you are in Fairbanks. That's what Fairbanks looks like. This is a mean annual temperature for the last almost 100 years. Modeled and measured, and typically in Fairbanks it was around -2, -1.5. This typical temperature is typical environment in Blackfoot Forest. In 75 it was jumped in circulation and it gets much warmer. And the first hit of the partial thawing of permafrost was in 90s, when this was combination of warmer climate and also deep snow. After that, it was about a cooling, but now the new wave after 2014 made permafrost really warm, and it started to thaw from the top down. So that's a different thing. It's not like increasing active layer and then refreezing completely. So what's happening? Next slide, please. Let's do the next slide, and then yeah. What's happening? This is the records of the places where permafrost start to thaw already. So what's happening? The summer thaw is so deep now that the winter freezing is not reaching the top of permafrost, and we developed a layer which we call phthalic, which is not freezing during the whole entire year. And this is the geophysical kind of indication of phthalic formation. See, that's how it happened during normal situation. By the end of the winter, everything is frozen way below zero. But after this phthalic develops, there is no much complete freezing. So it freezes a little bit from the top, seasonal frost, and then there is nothing there. And these curves, they look like cardiogram of person who actually dying. So this cardiogram of permafrost or upper permafrost. So, and that's what we start to observe. And can you go back just for a very short thing? So remember I showed in the 70s in Barrow or Death Horse the situation between comparison between the potential thaw, again potential thaw is this one, and potential freezing, start to get into this area where potential thaw will be more than potential freezing. That's exactly what's happening right now in Fairbanks area, and not in Fairbanks area. I will show the map. But of course, if some period of time when we have low snow or colder winter, this phthalic could refreeze. But at some point, like in Fairbanks area to somewhere like 35, maybe 32, when even with very cold winters and low snow, the potential thaw is still much larger than potential freezing. And in this case, permafrost will be thawing and thawing and thawing and thawing. So you can, huh? Yeah, it's already, yeah, that's the last picture actually. Some few photos which you can skip because you may see it. So it's not only Fairbanks phenomenon. The paper was just published in 22 when we show that out of about 55 sites where we saw this complete freeze up during the previous, say, 5 to 10 years, somewhere around 2018 and 19, thallic form. Out of 55, about half of them develop this thing in interior and Seward Peninsula and even as far as in Slavic area. So this is already a very widespread phenomenon. And just a few photos just to illustrate Utiqiagvik again on this picture. So that's how degrading ice wedges look in around Fairbanks. So it's a little bit more dramatic because there's some trees on top, sometimes houses on top. And yeah, in the last one is house. Yeah. Yeah. So sometimes it happens because the house was built by people who came from outside of Alaska and now they have no idea what it is, permafrost, and they built it as heated basement. And that's what happened. We don't care about it. That's very short thing, but maybe I will have time to put a little bit more in details later. Okay.
Thank you for that. Bringing up the Ming's presentation, probably have a time for one or two questions.
So glad you said, you showed that you could go down 120 meters in those boreholes, but you only reported 50 meters.
No, they're different depth. And I report, I report only 20 meters. It's just the most sensitive actually part of the.
Oh, but there was 50 meters on.
Yeah.
One plot.
Yeah, that course is 55 meters.
Oh, okay.
No, we report to the depth, to the full depth. And none of our boreholes more than 100 meters. When I said more than 100 meters, it's the USGS boreholes. The Arclock and Brooks started this program and very good flow. Was continuous, and I don't know what happened with this now because USGS tried to close its holes. And only Gary was fighting of his life to keep them open and measuring them, but I don't know what happened right now. They may be closed, and it's very valuable, observational system because they started about the same time in the 70s.
Okay.